short time schedule, yes. So this guidance has been prepared, and so it is also available on the REHVA webpage if somebody is interested to download the document. And in this document, we focus to HVAC professionals and how to operate the buildings in the current outbreak situation. And this is very clearly focused for non-residential, so offices, school buildings, so on. And assumption is that only very occasional occupants who are infected can be in such a buildings. So this is very much for the normal non-residential environment, and it is not dealing with healthcare and hospital issues, which are completely different. Let's say all the ventilation systems are different, and protection levels are much more better in hospitals. So it is evidence-based as much as possible. And the logic is, first we try to explain to engineers what is important, what are the transmission mechanisms, what is the existing evidence, and then we provide, let's say, a guidance how to operate mainly the ventilation systems, but also some air conditioning and heating issues included. So this is an illustration. You can see how the person will exhale such a virus, droplets and particles. So they will be in the air and will stay a long time, also settle on the surfaces, and it is very easy to spread to all other surfaces in the room, and indeed, if not ventilated, then the full room will be will have quite a high concentration. So regarding this transmission mechanism, these are quite complicated, but it is believed that close contact and via large droplets, which are then larger than 10 micrometers, this is the main mechanism. And this 1 meter distance is in the medical literature mainly, but they also apply a rule of thumb that it should be shouldn't be closer than 2 meters. And this is quite a complicated issue because it might even more depend on the concentration than just let's say a direct spread distance of the droplets, because this airborne transmission is quite evident, and especially for the smaller ones, smaller than 5 micrometers, they stay airborne for many hours, and actually gravity has no effect on these smaller ones. When this surface contact is well known, and also fecal-oral route has been reported, and there is existing evidence. So what is under discussion is what is a long-range airborne transmission mechanism, and how significant or possible it can be. There is not yet good evidence for a current SARS-CoV-2 virus, but it has been shown for the previous coronaviruses. And this is just a small explanation how this distance is so complicated. So how long it will take to settle down 1 meter for different size of the particles can be seen from the upper figure. And for example, for 30 micron, it's 2 meters distance if the airspeed is 5 centimeters per second in the room. But for example, for 10 micron, it's 15 meters, so it's very long distance. Particles can easily be spread in the room. So likely this close contact is even more, indeed it's a direct droplet contact, and might be very much a concentration issue, and actually this infectious concentration is not known, so we don't exactly know how high the concentration of virus particles needs to be to get the infection. This information is not available. But let's say some estimates by the researchers, if the ventilation is, for example, very small, 1 liter per second per person, then you likely easily get infection in any place of the room. But if the ventilation is adequate, when we speak about 10 liter per second per person, when the viruses are effectively ventilated out. So we also provide some latest evidence about the airborne transmission, and this is especially available from so-called super spreading events, which has happened in the environments where ventilation is very small. So best evidence what is emerging on that airborne transmission is really related to crowded spaces with very small ventilation. And that's indeed a good connection to U-CERT project and EPCs, where we see constantly that ventilation data is very seldom reported, and it was only in 45% of the EPCs the ventilation rate was possible to find. And that's some sort of a problem in such an outbreak situation especially. So what are the recommendations? So what can be done in existing buildings? It's possible to extend the operation time of the ventilation system. So REHVA recommends to start ventilation at full speed 2 hours before the occupancy, and then switch to lower speed also 2 hours after occupancy. And it is not recommended to switch ventilation off, but operate at lower speed at the night time and weekends. So this shouldn't be a significant energy penalty because of the springtime, and longer ventilation operation will enable to ventilate all particles out. Also, particles may resuspend from the surfaces. So basically, this is the reason why constant ventilation is needed. And what is important is actually outdoor air ventilation rate per person, but here it is impossible to provide any explicit guidance value, but basically we speak adequate ventilation, so it means according to existing standards, and with these existing standards you end up to somewhere close to 10 liters per second per person. And then it is also important for the exhaust ventilation from the toilets that these should be kept always on at full speed, and in such a way to create the underpressure, and when the ventilation direction is correct. It's also recommended not to open windows in the toilets. So in all other spaces, indeed, it is recommended to open the windows to boost the ventilation also in mechanically ventilated buildings, but in Europe, this toilet ventilation is very common. So it's very typical that in the toilet there is a window open, and this will take intake air to the full building in many cases in old buildings. And this is the situation what should be avoided in the outbreak conditions. So when there is quite good information available, what is the effect of the virus stability when we speak about the temperature and relative humidity, and this information is also provided. So basically it means that humidification is not an effective measure for this special virus, because at 65% relative humidity, room temperature 21, 23, the virus has shown very high stability in the laboratory tests. So for example, influenza virus shows different performance, but for this virus it is no use to apply additional humidification. And especially it is already a springtime, so we don't discuss about excessively low relative humidity indoors anymore. And the same applies for the air conditioning, basically lower temperatures, longer time of activity of the viruses, so no practical impacts. When it's some sort of a problem what might be in European buildings, what is let's say leakages in heat recovery sections, and how well these heat recovery equipments have been constructed, designed, and maintained. So recirculation indeed needs to be avoided, and for such a very common rotors which are used in office buildings, school buildings, whatever non-residential buildings, it is important that leakages are under control. And if equipment works as it should work, then the leakage is not more than 2%. So it's quite similar to plate heat exchangers. But if pressure differences are not correct, and it is so that on the exhaust air pressure is higher compared to supply side, then the leakage can increase even up to 20%. Data is available. So recommendation is to inspect the equipment and to take a pressure measurements to be sure that the leakages are under control. Then these rotors must have purge sector, which then will reduce the carryover leakage. So because the rotor will rotate from extract air to the supply air, and it is possible that some pollutants will be suspended in such a rotation process. But evidence is existing that this should not happen for particulate matter, and virus is also a particle in that context, but this transfer has been limited to gas-based pollutants, so for example tobacco smoke and other smells as a good examples. So basically no need to switch the rotors off. Leakage even does not depend on the rotation speed, but it is important that pressure differences are correct, and so these devices are correctly installed. So this is example how it should be in the air handling unit, so that it's on the suction side of the fans, and in this case arrows show the leakage direction, and it is possible to see that on the supply side we have a higher pressure. That is the situation as it should be. Well, recirculation is something what should be avoided, and if the systems are using recirculation, then they are needed to be switched to 100% outdoor air operation. So by opening outdoor air tamper and closing recirculation tamper very often can be done from BMS, or if cannot be done, then indeed can be applied manually. There are also some room level room conditioning units as fan coils or chill beams, which provide a local air circulation. And this might be more difficult to switch off. And for these ones, we recommend either to switch off, if not possible to switch off, then adjust their fans so that constant airflow, continuous airflow is provided through the fan coils independently on heating and cooling operation. And if fans are continuously operated, then there is no, let's say, viruses sediment in the filters, and you can expect a higher concentration when the unit will be switched on. So this is tried to be avoided by this continuous fans operation. What it comes to filtration and air cleaners, there is some information, but basically outdoor air filters are not effective for this size range of particles we are interested, and they do not need to be effective, and outdoor air is not also a source of viruses in this case, so this is a clean air, and this means that basically something extra measures are not needed for the outdoor air filters. If somebody wants to use air cleaners, then these might be useful if having HEPA level filters or with electrostatic filtration principles, but typically these have quite limited airflow, so they can operate effectively only in small rooms, typically less than 10 square meters, and to be located close to the person, so to the breathing zone. What is important when there are scheduled filter replacements or some maintenance work of ventilation systems, now it is important to follow common, let's say, common protective measures which are set by the regulation, I think in all European countries, but very often they haven't been followed so strictly, but in this situation strictly to follow and also to use this respiratory protection, that is indeed to be on the safe side, because filters may have some active microbial material on them, and this needs to be taken into account when replacing. So to summarize, we have made a list of 14 points. I will not repeat all of these, and so all these issues are briefly listed, and then indeed in the guidance document it is a longer information how to apply these 14 points. But at the end, as you can see, there are also something what you don't need to do. So do not change heating, cooling, and possible humidification set points. Do not plan duct cleaning for this period, and so on. And this is a short acknowledgement for the group working in this task force, preparing these guidelines, and actually this is already a second version, and it's possible that will be updated as new information will become available. So thank you. That's it. If somebody has a question.